Question 6. The diagram shows the curve y equals to 3x squared minus 2x plus 1 and the straight line y equals to 2x plus 5 intersecting at the points P and Q. Showing all your working, find the area of the shaded region. So the first thing you have to do in this kind of questions is that you have to get the points and the coordinates of P and Q. So to do that, you can see that these two equations here, 3x squared minus 2x plus 1 and 2x plus 5, they're all by y equals and y equals, so they have the same y at their intersecting points. So basically you have to equate them together just like that, and then from here you just simplify that. 4x plus 1 minus 5, which is minus 4. And then for this, you have to use the quadratic equation, which is x equals to minus b plus minus square root of b squared minus 4ac over 2a. If you cannot remember this, then you can also refer to page 2 of your exam paper, the quadratic equation, which is right here. Anyways, if you use this formula, you get minus b, which is minus 4, plus minus square root of b squared, which is minus 4 squared. This is b. Minus 4a, which is 3. C is minus 4. And then you get 2a, which is 3. So from here, if you simplify this, you get 4 plus minus 16 plus 4 times 3 times 4, that is 12 times 16, which is 12 times 16 is 192. 192, 6 equals to 4 plus minus square root of 16 plus 192, which is 208. Oh, I'm sorry, 4 times 3 times 4 is not 192. Four times 3 times 2. So 4 times 3 times 4 times 3 times 4. What am I saying? So it's 48. So it's 48. And 16 plus 48 is 64. So 64 and 6. So it is 4 plus minus square root of 64 is 8 over 6, which is 8 plus 4 is 12. So this is 4 plus minus 8 over 6. So 4 plus 8 is 12 over 6, or 4 minus 8 is minus 4 over 6. So it is 2 or minus 2 over 3. So this is their x values. So the x values of P and Q are 2 and for P is 2 and for Q is minus 2 over 3. And then from here you can get the y value by substituting the values, the x values, which is 2 and minus 2 over 3, inside the equations. Y equals to 3x squared minus 2x plus 1, or y equals to 2x plus 5. Let's go for the simpler one, y equals to 2x plus 5. So if you substitute 2 inside it, you get y equals to 2x, which is 2 plus 5. So it's 4 plus 5, so 9. So your first coordinate is 2, 9. Your second coordinate is y equals to 2 times minus 2 over 3 plus 5, which is minus 4 over 3 plus 5, which is minus 4 over 3 plus 5 is 11 over 3. So your second coordinate is minus 2 over 3 and 11 over 3. So from here you can already guess which one is P and which one is Q. Since Q is at the positive side, the x value will be positive since Q is here. So the positive x value is this one, so this must be Q, and P is negative, so the other one must be P. And from here, showing all your working, find the area of the shaded region. So from here, as you can see from the graph, how can you get the area of the shaded region? Well, you can do it by drawing straight vertical lines from the two intersecting points. And then from here, you can see that it becomes a trapezium. If you can see it, it looks like a trapezium, just like that. So what you do is you get the area of the whole trapezium, and then you minus, or you get rid of the part which is under the quadratic graph, so that you can get the area of the shaded region. Now this may sound complicated, but it will be easy if I just write it down. So the area of the trapezium is firstly the top, which is P, so this is minus 2 over 3. So this is minus 2 over 3, and Q is 2, so this is 2. So always label your graphs like this, because it will be easier to understand. So the top part is 11 over 3, and Q is at 9, so this 9. So the top part is 11 over 3 plus the bottom which is 9, and then you times the height of the trapezium, which is from here to here. So it's 2 minus 2 over 3, because you have to get the difference of these two values to get the length of the height basically. So times the height, which is 2 minus 2 over 3, divide this whole thing by 2. If you simplify this equation, you get 11 over 3 plus 9 times the height, which is 2 times 2 minus negative 2 over 3 divided by 2, you get 152 over 9. So this is your area of your trapezium. And now you have to get the area under the graph of the quadratic curve. So to do that, you have to use the integration, so the area under curve of, so which area do you have to get? You have to get the area under this graph, which is y equals to 3x squared minus 2x plus 1. So area under the curve of y equals to 3x squared minus 2x plus 1. So from here, you can use the integration method. So integration, you can use it for getting the area under the graph according to the x-axis. So for the curve, it is meeting, so we are limiting the range from 2 and minus 2 over 3. So the bigger number always goes to the top and the smaller number always goes to the bottom. And from here you just write the equation 3x squared minus 2x plus 1. Don't include the y because that doesn't count, as this both for x values, not the y values. And now you can write dx equals 2. So if you simplify this, if you integrate this equation here, you get 6. Oh, sorry, you get 3x cubed over 3 minus 2x squared divided by 2 plus x. And you just write the limits here, just like that. So how I got this equation is that for integration you always have to add 1 to the power of the value. So for example 3x squared, you just add the power 1, so you get power 1 to the x, so you get 3. And then you divide the power, and you divide the whole thing which is 3x cubed by the power you just got, which is 3. So divided by 3. So for this is minus 2x, so you add 1 here, so you get 1 plus 1, which is 2. Since the power is 2, you divide the whole thing by 2. And then for 1, there is no x. It basically means x to the power of 0. So x to the power of 0 plus 1, that will be x to the power of 1. So if you put x to the power of 1, the 1 will be 1 times x is still x. And if you divide it by 1, then you still get x. So basically, if you simplify this, you get x cubed minus x squared plus x 2 over 3 minus 2 over 3. Then from here you can just simplify it. To give you 2 cubed minus 2 squared plus 2 minus 2 over 3 cubed minus 2 over 3 squared plus 2 over 3. Forgot to add the negative signs. Always remember the negative signs in front of the 2 over 3. This is actually negative 2 over 3. And then if you use a calculator, you get 2 cubed minus 2 squared plus 2 minus 2 over 3 cubed minus 2 over 3 squared plus minus 2 over 3. Always remember to add the negative sign if you have forgotten. And you get 200 over 27. So after this, you have to get the area of the shaded region, which is this part right here, the blue part. So what you have to do is, you have to minus the area of the area under the graph of the curve, area under the curve, from the area of the trapezium. So basically, if I write everything down here, the answer would be area of the trapezium, which we got is 152 over 9. So it's 152 over 9 minus the area under the curve, which is here. So it is 200 over 27. So the answer is 152 over 9 minus 200, minus 200 over 27, which you get 256 over 27. So you get 256 over 27. And that is your answer. Question 7a. Solve log 3x plus log 9x equals to 12. So to do this question, you have to change the base, which is 3 and 9, change them to be the same with each other. So you can either change the log 3x base to 9, or you can either change the base 9 to base 3. So to change a base of a logarithm function, you have to firstly, let's say if you want to change log 3x to the base of 9, so if you want to change the base, it has to be, so log 3x is, if you want to change the base of 9, you have to put log 9 over log 9, you put that, which is a fraction, and you have to put the x to the top and the base, or the original base, to the bottom. Or if you want to change the log 9x to log 3x, it is still the same thing. You put it as log 3 and put them as the same base. And then from here, you just put the x to the top and the base, original base, to the bottom. Just like that. So in this question, I would rather change the log 3x base to log 9. So I will use this one. Okay, so if I just erase this one, it's like that. And then from here, so since log 3x, if you want to change to log base 9, it will become like this. So I can rewrite the equation as just like that. And then from here, using my calculator, log 9/3 would be, so log 9/3 would be half. So it would be log 9x divided by half plus log 9x equals to 12. So log 9x divided by half would be 2. So it would be 2 log 9x plus log 9x equals to 12. And then from here, I can add these two together. So 2 plus 1 is 3 log 9x equals to 12. And I can move the 3 over to the right side, as right now this is 3 times log 9x, so I can do log 9x and equals to 12 divided by 3. So log 9x should equals to 4. And now to get the x value, x should equals to 9 to the power of 4. So this would be 6561. And that is the answer. B. Solve log 4 bracket 3y squared minus 10 bracket equals to 2 log base 4 bracket y minus 1 bracket plus half. So the first thing you have to do is this 2 right here, you can actually move it as a power to the log. So basically, let's, for example, if I have log 2 log 5 x, that will become can also mean log 5x squared. So using this example, I can apply to here. So this 2 can be the power of y minus 1. So that would be log 4 y minus 1 squared plus half. And then from here, I can move the log 4 y minus 1, this whole thing, to the other side. So it will become log 4 3y squared minus 10 minus log 4 y minus 1 squared equals to half. And then from here, I can use the logarithmic division rule, which is if any two logarithms are subtracting each other, then you can put it as a division rule, which is log 4 3y squared minus 10 over y minus 1 squared equals to half. And then from here, you can move the 4 to the right side. So this basically means 3y squared minus 10 y minus 1 squared equals to 4 to the power of half, or square root of 4. So 3y squared minus 10 y minus 1 squared equals to 2. And if I just rewrite the equation here, 3y squared minus 10 y minus 1 squared equals to 2. And then from here, I can move the y minus 1 squared to the other side, so it will become 3y squared minus 10 equals to 2 y minus 1 squared. So after that, you expand this equation so that it becomes y squared minus 2y plus 1, and then you can expand that. It becomes like this, and then if you simplify all this, it will become 3 minus 2, which is y squared. We'll move 4y to the other side, it becomes positive 4y minus 10 minus 2 minus 12 equals to 0. And then from here, you can use the factorization method. So it is 2 and 6 minus 2, 6, that is 4. Yep, that is correct. So it becomes y minus 2 and y plus 6 equals to 0. So y equals to 2 or y equals to minus 6. But you see, if it's negative 6, a logarithmic function can never become a negative. That means that, example, if you have log to the base of 4, and let's say you have a negative number like negative 5 or negative any number, it will become undefined. So if I just type in here, I can show you that if you have log 4 to minus 5, it will say syntax error because because of the bracket. But if I just get rid of the bracket like that, then it will become math error. So the answer can only be a positive value, so which in this case is 2. So y equals to 2 only, it cannot be minus 6. So from here you can just erase this equation, this answer. And that's it. The answer is y equals to 2 only.